Throughout industry, people are asking questions, the answers to which directly influence industrial efficiency.
Stop this job, Jack. This material is worse than the last lot. I wonder what these other people are using.
Right now, I could do with some sound advice.
A ready market for the first company to get them into production. Nice work if you can get it, but how?
These are just 3 of the thousands of unanswered questions that come up every day. Yet, there are so many sources of information, able and willing to provide the answers. The Department of Scientific and Industrial Research, DSIR, runs 14 research stations, the best known of these being the National Physical Laboratory, a vast organization which is itself divided into 9 divisions, each concerned with a different subject. Other laboratories of the DSIR work on such subjects as water pollution, building research, mechanical engineering, road construction, pest infestation, timber, and food, an increasingly complex but vital subject. The program of research is organized so that the maximum benefit will be given to industry as a whole. These are government laboratories, and the results of their research are readily available to all. The Motor Industry Research Association has been established by the industry itself. Similar associations exist in other industries. Altogether, there are some 40 research associations set up to study their members' common technical problems. They cover trades as diverse as steel and lace, food and furniture, and are staffed and equipped to undertake research, often of a long-term nature, which will directly benefit their member firms. Frequent reports are issued and members kept fully informed of technical progress at home and overseas. They can also consult an information section about their day-to-day problems. The scope of work varies. It may involve advice on testing or be of a much more sweeping nature. For example, the British Iron and Steel Research Association has developed a method for continuous casting of steel. It is the member firms themselves who decide which problems are to be tackled. 15,000 companies belong to research associations. They pay an annual subscription, and in addition, each association receives a grant from public funds. Besides the cooperative research associations and government laboratories, though, there are thousands of consultants who accept private research commissions in all branches of science and technology. The one-man consultants are usually specialists working in an advisory capacity only. But the larger consultant organizations are staffed by practical men with considerable experience and equipped for both experimental and development work. They are particularly valuable in the development of new equipment and apparatus. Small firms using their facilities can save the full-time employment of a technical specialist, which is often wasteful. Calling in a consultant still gives the problem to a specialist and is often the most economic arrangement. The cheapest and perhaps the most fruitful sources of information are the reference and lending libraries. The Science Museum in Kensington has a large collection of literature which they will lend to industry. The Patent Office, too, has one of the finest technical reference libraries in Britain. Here, every patented idea that has helped to develop industry can be seen, and trade journals from all over the world studied. These, however, are only 2 of the thousands of libraries, private and public, from whose shelves many an idea has sprung. But all these sources of technical information will be wasted unless someone in each firm takes the trouble to look for new ideas and ways to develop them. Oxted Mill lies in the heart of the Surrey countryside. It lay derelict for many years until in 1952 it was reopened as a workshop for light engineering. For our purposes, it could equally well be a chemical plant or a textile factory. What interests us is that here a man developed his idea.
The run of 3,000? Yes, I've got the sample in front of me. You confirm the order by post tonight? Many thanks. Goodbye. My name is Ian Nichols. I started Oxted Mill Limited back in 1952 with much enthusiasm. First 3 balance sheets were promising. There was plenty of work. Our operators were keen. The machines were well maintained. But then we found our profits beginning to fall away. And I thought I knew the reason why. We had gradually been changing over more and more to capstan lathe work, and the economics of capstan operations depends mainly on the amount of work which each operator can perform and his wages. But our policy is to pay operators as much as we can and then see that the machines give sufficient output to make this profitable. Hand-operated capstans are such that each machine monopolizes its operator all the time it is running. During the cycle, he can do nothing else. If he wants to rest or gauge the last component, the machine automatically becomes idle. As things were, there was nothing that the operator or I could do about it. I had taken a long time to find this out. I resolved to waste no time in searching for the answer. One afternoon a week, I used to sit back with the trade papers. I'd already taken many first-rate ideas from such literature. An article on the use of compressed air in production made me pause. Someone had been using it to control drill feeds. Maybe it could help me. I knew very little about compressed air, but as long as there was a chance that it might solve my particular problem, I was interested. Trade exhibitions are often very useful sources of information, and so I always make a point of going to as many as I can in search of new ideas. On this occasion, I was particularly on the lookout for suppliers of air hydraulic feed units. I prefer having this type of demonstration at an exhibition where I am their guest and can leave when I want. I explained, rather inadequately, how I hoped that compressed air might help me. If part of the capstan cycle, such as the cross slide, could be made automatic, it would give the operator time to gauge his last component without stopping production. The supplier took it from there. He could not have been more helpful. His explanations were clear and reasonably unbiased. By the time I left that exhibition stand, I felt I was making some progress. Fully aware that my knowledge was still superficial, I was interested when a paper on this subject was being read to the Institution of Production Engineers, of which I am a member. The lecture and discussions that followed were most valuable. But there is another side of these evenings which appeals to me. There are plenty of chances of meeting fellow members who are probably up against similar problems. If I have an idea and then keep it secret, I never know what it is really worth. But if I exchange it with somebody for another idea, I immediately have 2 ideas. And as time goes by, these continue to multiply. The self-activated cross slide worked. The operator was given valuable time to do 101 odd jobs. I had by then already begun to realize that complete automation of the capstan lathe was possible by similar principles, but it would need a fairly complicated system of electrical sequence switches to program the various movements and select the right speeds and feeds. My own knowledge of electricity ended with a vague memory of Ohm's law, so I had to re-educate myself. I used to be overawed by the atmosphere of libraries until I realized that somewhere in the thousands of libraries in Britain were the answers to every question I was likely to ask. I found all the information I needed on motors and controls laid out very simply in a British Electrical Development Association handbook. Back at the mill, I discovered that one of my setters had once been an electrician. His practical experience and my ideas were pooled to decide upon the simplest and best layout for programming the various sequences of machine movement. By careful planning in order to incorporate as much ready-made equipment as possible, the cost was reasonable, and our hopes were translated into reality. The prototype capstan lathe, with uninterrupted self-act, commenced its trial period. Just when we thought we had things working, we hit a snag. The air actuation was rather rougher than hand operation. The springs could not stand it. Once more, we had to start thinking. Any member of the Production Engineering Research Association can, in return for a small annual subscription, get helped out with any technical queries they care to put up. I explained my difficulty, and they assured me that they'd had several problems on spring failure in the past. At their headquarters, they have a library for dealing with this sort of problem and can tackle it quickly and authoritatively. Soon I had a spring on which I knew I could rely. That was the final piece of information I needed to make my fully automatic capstan lathes work. Few of the principles that I used on my automatic capstan lathes were entirely new inventions. Difficult problems have to be answered, but much information and hundreds of good ideas were just waiting to be picked up from many different sources. Probably the most efficient way of harvesting such ideas is to make this the responsibility of one man. The post obviously cannot be full-time in a small firm, but it should be his responsibility to keep a fresh outlook and continually search for alternative methods of tackling each job in the factory. Success depends on his enthusiasm and drive. He must go out after ideas. He must say to himself at regular intervals, as I keep saying, "Today I intend to learn something valuable that I did not know before."
The key to prosperity of smaller industries is an efficient marriage between those asking questions and those who can supply the answers. There are plenty of people waiting to help next time you have just an idea.